Hi, today we're going to be talking about the blood flow of the heart. This can be kind of complicated, but one of the easier ways to visualize it is to make a grid that looks like this, with 4 boxes to represent the 4 chambers. This is the right atrium, this is the right ventricle, this is the left atrium, and this is the left ventricle. The right and left side is flipped on paper because we want to be calling the right and left sides what it would be on a person, like in human anatomical position. The atria are separated by a wall called the interatrial septum, and the ventricles are separated by the interventricular septum. So the overall job of the heart is to take deoxygenated blood from the rest of the body and oxygenate it and then send it back out. So let's go through the pathway. So the deoxygenated blood first enters the heart into the right atrium. So the way it enters is through 2 veins called the inferior vena cava and the superior vena cava. The inferior vena cava brings in blood from areas of the body under the heart, and the superior vena cava brings in blood from areas of the body above the heart. From the right atrium, the blood then travels through a valve called the tricuspid valve to the right ventricle. The way it gets there is because of an electrical impulse from a node over here in the top of the right atrium called the sinoatrial node, or the SA node. It causes both atria to contract, which pushes blood to the ventricles. The SA node is also nicknamed the natural pacemaker of the heart because without it sending the electrical impulse out, the normal sinus rhythm of the heart would not be maintained. Usually when there's a problem in the heart, it's either a physical problem with a valve or something, or it's an electrical problem with the nodes and impulses, which is why we sometimes say that to fix the heart, we would either need a plumber or an electrician. But anyway, next, when the blood makes it through the tricuspid to the right ventricle, it's still deoxygenated, so it needs to take a trip to the lungs so that the lungs can oxygenate it. It does this through a valve called a pulmonary semilunar valve, so that brings it to the pulmonary arteries, which brings it to the lungs. The pulmonary artery is the only artery that carries deoxygenated blood, because usually veins do that. There's another node called the atrioventricular node that causes the ventricles to contract that actually pushes the blood through the pulmonary semilunar valve. This node is right here on the bottom floor of the right atrium. It works by sending an impulse down over here to a bundle of muscle fibers called the bundle of His, and then the impulse travels further down to nerve fibers called the Purkinje fibers, and these help the ventricles contract. So both the bundle of His and Purkinje fibers are just named after the people who discovered them. So once the ventricles contract, the blood can travel from the right atrium through the pulmonary semilunar valve to the pulmonary arteries to the lungs on both sides. Once the lungs oxygenate the blood, it then travels back into the heart into the left atrium through the pulmonary veins. There are 2 of them on each side. Once again, these are the only veins that carry oxygenated blood because usually arteries do that. From the left atrium, the blood then travels through the mitral valve, which is also called the bicuspid valve. It does this because the atria contract due to the sinoatrial node. The left atrium then carries the oxygenated blood to the aorta through the aortic semilunar valve. That happens because the ventricles contracted from the AV node. The aorta then carries the oxygenated blood throughout the whole body, and it's the main artery of the whole body. So throughout this whole process, the blood entered the heart, deoxygenated, and now it's leaving the heart oxygenated. It can look a little confusing by the end, but if you draw it out on your own, it can help a lot with understanding it. Thanks for watching!